Hello everyone. Sorry I can't be there with you today, but hopefully with this video lesson it kind of feels like I'm there. Remember, usually we start off with questions from the homework, but because I'm not there to answer them, save your questions if you have any for tomorrow and we can take them up tomorrow. Today we're looking at functions. So functions, we're first going to look at the definition of what a function is. A function is a graph that has only one output, that's a y value, for each input, and that's the x value. So on our graph, for every x value that we have, we should only ever have one y value. If our graph has two y values for one x value, then it's not considered a function. One thing that we can use is what's called this vertical line test. The vertical line test is a test that we can use on a graph to help us determine if a relation is a function or not. Now what we do with the vertical line test is if a vertical line crosses a relation at more than one point, then it's not a function. So basically we can take a vertical line and run it across our graph, and it can be imaginary in your head, or you can use a ruler or something like that across the graph. And if it's somewhere along that line touches our graph at more than one point, then we know that it's not a function. If it only ever touches our graph at one point, then we know that it is a function. If people need more time to write down these notes, please pause the video at this time and then continue when you're ready. So we're going to look at some examples here, and I'm just going to grab a vertical line for us to run through our vertical line test. So here's my vertical line, and we're going to look at this example here, and we're going to take our vertical line and run it across our graph. But as we run it across, look at several points, especially right here, that it hits our graph at two different points. It hits our graph here, and it also hits our graph here. So because of that, we know that it is not a function. Make this a little bit smaller here. So it fails this vertical line test since that vertical line hits our graph at two different points. Let's do it for our next one here. So again, we have our vertical line. We're running it across our graph. Keep going. So as we're running our vertical line across our graph, at no point does it ever hit more than one point on our graph. So it passes our vertical line test. So therefore, it is considered a function. Similarly, we're going to do that to our other two graphs down here. So again, we're going to draw our vertical line and run it across. But as we run it across, we see that for the majority of the time, it's hitting 2 points here on our graph, so it's not considered a function. And then let's take a look at our last graph here. Again, we take this vertical line, drag it across. So far, so good. Oh, but at this point here, it actually hits at more than one point. It hits at 3 different points on our graph. Even though it doesn't on this side and it doesn't on this side, because it hits at multiple points in the middle, it's not considered a function. Again, at this point in time, if people need more time to write this in their notes, please pause the video. So in this class, besides being able to look at graphs and tell that they're functions, we need to use what's called function notation. And from now on, we are going to use this function notation in this course, and any course that you take after this will continue to use this function notation. So first off, what is function notation? So if an equation is a function, it means that each input will have just one output. So if we have one x value and plug it into our equation, we will only get one y value. And that's been true so far. We saw that on Friday when we did our table of values. When we plug in our x value, we only ever found the one y value that we used in our table of values. So we're going to see a little bit of an example here. So we have this general equation here of a straight line. Y is equal to 3x minus 5. This is the type of equation that you're used to seeing. But to put it in function notation, we can write that as instead of having a y equals, the output is going to be changed to an f with an x. So instead of writing a y, we're writing f bracket x. And that equals our 3x minus 5. So y equals 3x minus 5 is the same as fx equals 3x minus 5, but this one here is written in function notation. Now, the last little piece here is how this is properly worded in terms of function notation. Just going to move it up a little bit. The name of this function is f, and the output of the function is fx. So the entire thing, this entire thing here is our output, which is our value of the y, but we call this function f. And we can use different letters. We could put a g in front of there, so we'd have a function called g. But again, the g with the x, the entire thing would be the output or the y value. So the fx is the value of the function f at the value of x. So when we take our x value and plug it into our equation, we're finding the value of f at a certain value of x. And the way that this is properly read is we can say f at x or f of x. Again, at this point, if people need more time to put this in their notes, please pause the video. So now that we know how to properly word function notation and we have the proper notation of function notation, we can now show different outputs. So an example that we're going to look at is what is the output of the following function when x is equal to 3. So we have our f at x equals 3x minus 5. But what we're going to do is we're going to plug in the value that x is equal to 3. Because that's what it asks us to find. What is the value of this function when x is equal to 3? So in our function, what we're going to do is we're going to replace every x with a 3. So we have f of x here. Now we're finding the value of f at 3. Then in our function here, again, we're going to replace all our x values with the value of 3. So that we get 3 bracket 3 minus 5. And then we can solve that out to see what is that value. So we do 3 times 3, which is 9. And then we need to minus out the 5. So 9 minus 5 is 4. So we know that the value of f at 3, when our x value is 3, our y value is equal to a value of 4. So to answer our question of what the output is, therefore the output when x is equal to 3 is the value of 4. Again, at this point, if people need time to write the notes, please pause the video. We're going to continue to look at other examples, but with slightly more complicated functions. So in this example, we have if f at x is equal to 3 bracket x minus 2 squared minus 1, we're asked to find two different values of f. So let's start off with f at negative 2. So in our function, we're taking our x values and plugging in, wherever there's an x, we're plugging in a negative 2. So we have 3 bracket negative 2 minus 2, and that is squared. And then we have the minus 1. So now that we've plugged in our x value, we've plugged in a negative 2 instead of our x in our function. Now we need to solve it out. So follow our BEDMAS rules. We are going to do what's inside the brackets first. So negative 2 minus 2 gives us a negative 4. And that's still squared. And then we have our minus 1 at the end. Then we do our exponent, so negative 4 squared is a positive 16. Remember, any number squared, even if it's negative, will always give us a positive answer. And then we need to do 3 multiplied by 16. Which is 48. Oops. There we go, 48. And then we have the minus 1. And then minus out our 1, so we get the value of 47. So in this function, when our x is equal to negative 2, we have the value of negative 47. Similarly, we're going to do that with f at 5 and figure out what is our output, what is our y value, when x is equal to 5. So again, in our function, wherever we see an x, we're plugging in the value of 5. So in our function, I have the 5 in place of the x. So now I'm going to solve that out. Again, follow your BEDMAS rules. So 5 minus 2 is 3. And then we have 3 squared, which is 9. Three times by 9, which is 27. And then we minus out the 1. So our y value is 26, or our final answer of f at 5 is equal to 26. And I'm just going to box my answers here. For the final part of our question. Okay, let's take a look at the next piece. So for the next one, again, we're given this function here, that 3x minus 2 squared minus 1, and we're asked to find this combination. So we're asked to find the value of f at 2 minus the value of f at 1. So we're going to do this in little parts. So the first thing that we're going to do is we're going to find the value of f at 2. So the value of f at 2, let's put that in square brackets so that we know that it's separate from this one here. So we have 3. In our place of our x, we're placing the value of a 2. So then we have minus 2 squared minus 1. And then that's the end of that one, so we're going to throw in a square bracket. Then we have our minus sign. And then we need to find out the value of f at 1. So again, in square brackets, we're going to take our function and plug in our value of x when it's equal to 1. So we have 3 bracket 1 minus 2 squared squared, there we go, minus 1, and then end off our bracket. You could also do this piece by piece off to the side if you like. Again, do whatever you are most comfortable with. So let's figure out what this value is here inside of these square brackets. So we have 2 minus 2, that's 0. In our second set of brackets here, we're going to do the 1 minus 2 inside the round bracket, so that is negative 1. And then our next step is to do our exponents. So we square. 0 squared is still 0. And negative 1 squared here is a positive 1. Then let's do our multiplication. 3 times 0 is still 0. And 3 times 1 here is 3. And then let's do our minus. So 0 minus 1 is negative 1. And 3 minus 1 is 2. Now our last step is to put these two square brackets together by using the minus in the middle. So we have negative 1 minus a 2. So our final answer is negative 3. So when we do f at 2 minus f at 1, we get the y value or the f value at negative 3. And again, let's box our final answer here. I'm going to take a look at the next example. So in this example here, let's actually change this to a. In our next example here, we're again given this function, but this time we're asked to find negative 3, or f at negative 3a minus 3. In this case, we have a variable that's being plugged into our equation. So what that means is that we're going to end up with a variable in our final answer. There won't be a single number that our answer will be in. We will have a variable in our final answer. So let's just make a little side note about that. So in all the other ones that we've seen, we've always gotten a single number that has been our solution. But again, because there's a variable that we're plugging in, we no longer are going to just get a single answer as in our solution. So that's why I've just written this little note here. So that'd be good to throw in your notes so that when you're looking at the example, you remember. Okay, so let's take a look at this here. Again, we're trying to find f at negative 3a minus 3. So the steps that we're going to follow are the same. In our function here, wherever we see an x, we are plugging in our value of minus 3a minus 3. So this entire thing here is taking the place of our x up here. So I'm just going to make that a little different color just so that's a little bit easier to see where that x is in our function here. We're replacing it with everything that's inside our brackets here, which is our negative 3a minus 3. Now we continue on with the rest of our function. Inside those brackets, we still have a minus 2. Then we have bracket squared. And then we have the minus 1 at the end. So again, all we have done on this line so far is to take our function here and plug in where the x is, the x value, which is negative 3a minus 3. Now that we've done that, again, our same step is the same. We're going to simplify out as much as we can. So inside our bracket here, we look at what like terms we have. We have the negative 3 and the negative 2 that are like terms, so we can put them together. So we still have a negative 3a, but now it's minus by a 5. And it's still all squared. And then minus 1. Now in this case, when we look inside our bracket here, there's nothing else that we can simplify in that bracket because one has a variable and one doesn't. They're not like terms, so we can't put them together. So then what does this part look like here when we have two terms inside of a bracket that is squared? I'm hoping that some of you were remembering that means that we have that bracket written twice. It's that bracket multiplied by itself. So we have negative 3a minus 5 written twice, and that's what that squared around those brackets mean when we have a variable inside those brackets. And hopefully you're remembering that that means we have to FOIL. So now here in our answer, we still have the 3 out front, but we're going to FOIL our brackets. So we'll redo our first, so negative 3a multiplied by negative 3a. That's going to give us a positive 9a squared. And then we do our outside, so negative 3a multiplied by negative 5. That's going to give us a positive 15a. And then we do our insides, negative 5 multiplied by negative 3a. That gives us another positive 15a. And then our lasts, so negative 5 multiplied by negative 5 gives us a positive 25. And then we still have that negative 1 outside those brackets to carry down. Then remember our next step in foiling is always to collect our like terms, which are the 2 in the middle. So we have 3 bracket 9a squared plus, now when we put these two terms together in the middle, we get 30a, and then plus 25, and bracket minus 1. Now we can deal with this 3 outside the bracket. So remember, to deal with that, we take this negative 3 and multiply it by everything inside our bracket. We're going to take this negative 3 and multiply it there, and also multiply it there. So we get 3 multiplied by 9a squared, which gives us 27a squared. Then 3 multiplied by 30, we get plus a 90a. And then 3 multiplied by 25 gives us a plus 27. And then we carry through that negative 1 at the end. And our last step is to put our like terms together, and the only like terms we have is a plus 75 and plus a negative 1. So we get 27a squared plus 90a plus 74. And that is our final answer for this, because there is no other simplifying we can do. And again, because we started with the variable inside the brackets, we're going to end up with a variable in our final answer. So let's square off our final answer here. So again, if you need more time to write down that, please pause the video. I'm going to move on to the next example. So again, we have our last example here. Again, I'm going to change that variable to an a. So what I want you to do is I want you to try this one by yourself. So I want to see if you can figure out what the value of 2a plus 1 is by plugging it into this function, just like we did in the previous example. So at this time, please pause the video. Once all the students have given it a try and have their answer, then play the video and I'll show the solution. Okay, so hopefully everyone has now given it a try and you all have your solution. So let's just double check to make sure that they are correct. So we're plugging in a 2a plus 1 into our brackets where there is an x. Then we have the minus 2 squared minus 1. And let's simplify inside our bracket. So we get 2a minus 1 inside the brackets, and that's a squared minus 1. And then that means that we have two of those brackets, 2a minus 1 multiplied by 2a minus 1 minus the 1 at the end. Then let's do our foiling. So we get 4a squared minus 2a minus 2a plus 1 minus our 1. Simplify out. So we get minus 4a plus 1. Then distribute that 3 inside your brackets, so we get 12a squared minus 12a plus 3, and then minus the 1. So our final answer is 12a squared minus 12a plus 2. So I'm hoping that most of you got that answer when you tried it yourself. If not, then double check to see where you went wrong. Okay, so that is it for the lesson. You do have some follow-up practice questions that are in your textbook for you to practice your skills on this. Please note that the assignment 1 that you get handed out on Friday is due tomorrow. So please make sure that you either use your class time to work on the homework or use your class time to work on the assignment. Also, please note that there will be a quiz on this Wednesday of this week. This quiz will be on the table of values and differences, so what we were doing on Friday. It will also include a little bit of questions about whether the graph is a function or not. And then also it'll have a question about stating the domain and range. Now this is something new for you guys, but we will see that in class tomorrow. So please make sure that you are aware that the quiz will be this week on Wednesday on these topics. Other than that, I hope you have a great day and I will see you tomorrow.